we're going to finish up our foldable. We're going to be in the zero exponent property part first. And the zero exponent property states that any integer to the power of 0 equals 1. This is probably the easiest property to remember, but it might be confusing as to where does the 1 come from. Well, let's kind of look at the examples up here. We've got 2 cubed, which is 2 times 2 times 2 equals 8. 2 squared means I'm multiplying by 1 less 2 than I was up here, and I get 4. So I could think about, I'm actually getting rid of this 2 right here by doing 8 divided by 2, and that gives me 4. And then 2 to the first power, that just means I'm going to have 2 as a single factor, not being multiplied by anything. Again, I'm getting rid of a 2 right here to get down to here, from 2 squared to 2 to the first. So I could honestly think about saying I'm doing 4 divided by 2, and that would give me 2. And then 2 to the 0 power means I'm not multiplying anything. But to get rid of that 2 I did have, 2 divided by 2 gives me 1. The math behind it really is the multiplicative identity property, which means any number times 1 is that number. So it goes back to that, but you can just think about it as any number to the 0 power is equal to 1, or you can think about it as what I did up here. Each time I'm getting rid of one of my factors, I'm dividing, and eventually I would get down to 1. Anything to the 0 power is equal to 1. 3 to the 0 power, if you look at our examples, is equal to 1. Negative 6 to the 0 power equals 1. Negative 49 to the 0 power equals 1. 1 to the 0 power also equals 1. Now the negative exponent property, negative exponents represent small numbers. Negative exponent means to take the reciprocal. Well, let's continue with the 2 cubed example up here. Again, we're going with 2 to the 0 power equals 1. You can actually go past 0 and you can have negative exponents. That's why our properties are called integer exponent properties, because you can have negative whole numbers right here. When we're talking about these negative exponents, we're talking about small numbers. Fractions are small numbers. If you look at 2 to the first power and you remember that it equals 2, 2 to the negative first power equals 1/2. 2 and 1/2 are reciprocals. And that's what the negative exponent property says, is that you're going to take the reciprocal. 2 squared, 2 times 2 is 4. 2 to the negative second power is the same thing as using the reciprocal, 1 over 2 squared, 1/2 times 1/2, 1/4. 1/4 and 4 are reciprocals of one another. 2 cubed is equal to 8. 2 to the negative third power is 1 over 2 cubed. And that's the same thing as 1/2 times 1/2 times 1/2, 1/8. 1/8 and 8 are reciprocals. Let's look at example A right here. We've got 3 to the negative second power. Well, if I think about, let's think about 3 squared. We know 3 squared is the same thing as 9. And then if I went down to 3 to the first, I would get rid of one of my 3's by dividing by 3. And then we already know 3 to the 0 power is equal to 1, and that's dividing by another 3. 3 to the negative first power, I would divide by 3 again. 1 divided by 3 is 1/3. And then 3 to the negative second power, divide by 3 again. And that's the same thing as keep, change, flip. And that gives me 1/9. But you don't have to do all of that work each time. You can just say, I'm going to rewrite this using its reciprocal. Once you've done that, you don't have to have the negative anymore. And you can simplify this down. 3 squared is 9. So 3 to the negative second power is the same thing as 1/9. It is a small number. It's a fraction. And we simplified it by using the reciprocal of 3 to the negative second power, which is 1 over 3 to the second power. Negative 6 to the negative fourth power, you can rewrite this as 1 over negative 6 to the fourth power. And if I do negative 6 times negative 6 times negative 6 times negative 6, I get positive 1,296. 1 over 1,296. 4 to the negative third power is the same thing as 1 over 4 to the third power. And you can simplify this. 4 times 4 times 4 is 64. Remember, you can check these. If I just did normal 4 cubed, I get 64. So 4 to the negative cube, or 4 raised to the negative third power, is the same thing as 1 over 64. And 1 over 5 to the first power is the same thing as 5 to the negative first power. And 5 to the first power is just 5. 5 to the negative first power is the same thing as 1/5. Now you can do the opposite of this. You can rewrite expressions that don't have negative exponents. You can rewrite them with negative exponents. 1 over h to the third power would be the same thing as h to the negative third power. 1 over 81. You can break down 81 into 9 times 9, which is the same thing as 9 squared. And you can rewrite that as 9 to the negative second power. Or you really could just say that this is the same thing as 1 over 81 to the first power, which would be 81 to the negative first power. Those two answers are equal. Alright, you now have your foldable for the properties of integer exponents all the way filled out.